Dear students, the topic is bioreactor or fermenter. Before going to the topic, please subscribe my channel, press the bell icon for notifications, like, share among your friends and comment. We can discuss about bioreactor or fermenter. You know, a bioreactor is a fermentation tank used for the production of various chemicals and biological reactions. It is a closed container with adequate arrangement for aeration, agitation, temperature control, pH control and drain overflow when to remove the waste biomass of cultured microorganisms along with their product. When we examine the basic features of a fermenter, consists of an agitator system, an oxygen delivery system, a foam control system, temperature control system, pH control system, sampling ports, a cleaning and sterilization system, a sump and dump line for emptying of the reactor. We can see in detail one by one about these parts of the bioreactor. A vessel used for fermentation or other process. A typical bioreactor used for microbial fermentation is shown in the following figure. Laboratory scale bioreactors with liquid volumes of less than 10 liter are constructed out of Pyrex glass. For larger reactors, stainless steel is used. Agitation system. The function of the agitation system is to provide good mixing and thus increase mass transfer rate through the bulk liquid and bubble boundary layers. Provide the appropriate shear condition required for the breaking up of bubbles. The agitation system consists of the agitator and the baffles. The baffles are used to break the liquid flow to increase turbulence and mixing efficiency. The next is oxygen delivery system. The oxygen delivery system consists of a compressor, inlet air sterilization system, and air spouger, exit air sterilization system. The condenser. In small reactors, the exit air system will typically include a condenser. Condenser is a simple heat exchanger through which cool water is passed. Volatile materials and water vapor condense on the inner condenser surface. This minimizes water evaporation and the loss of volatiles. Drying the air also prevents blocking of the exit air filter with water. Oxygen delivery system, that is purger. During the emptying of a fermenter, it is important that the air feed valve is closed. This will minimize the contamination of the inlet air line. Bubbles arise directly beneath the impeller. Shear forces are highest around the impeller. This maximizes efficiency of bubble breakup. Here explains the importance of impeller speed. The shear forces that an impeller generates play a major role in determining bubble size. If the impeller speed is too slow, then the bubble will not be broken down. In addition, if the impeller speed is too slow, then the bubble will tend to rise directly to the surface due to their buoyancy. Here in this diagram, it shows slow impeller speed and fast impeller speed. Next is the foam control system. Foam control is an essential element of the operation of a sparged bioreactor. The anti-foam requirements will depend on the nature of the medium, the products produced by the fermentation, the aeration rate and stirrer speed, use of mechanical foam control devices, the headspace volume, and the condenser temperature. Foam is typically detected using two conductivity or level probes. When the upper level probe is above the foam level, no current will pass between the level probe and the anti-foam pump remains turned off. When the upper level probe is immersed in the foam layer, the current is carried in the foam. This causes the anti-foam to turn on. One probe is immersed in the fermentation liquid while the other placed above the liquid level. When the foam reaches the upper probe, a current is carried through the foam. The detection of a current by the foam controller results in the activation of a pump and the anti-foam is then added until the form subsides. Temperature control system. The temperature control system consists of temperature probes and heat transfer system. Typically, the heat transfer system will use a jacket to transfer heat in or out of the reactor. The jacket is a shell which surrounds part of the reactor. The liquid in the jacket does not come in direct contact with the fermentation fluid. In pilot and production scale reactors, heating is typically only required during the initial stages and final stages of the fermentation, as most processes which occur during a fermentation process, including the biological reactions, chemical reactions, mixing, and all are exothermic. pH control system, that is neutralizing agents. The neutralizing agents used to control pH should be non-corrosive. They should also be non-toxic to cells when diluted in the medium. Potassium hydroxide is preferred to NaOH as potassium ion tend to be less toxic to cell than sodium ions. However, potassium hydroxide is more expensive than sodium hydroxide. Sodium carbonate is also commonly used in small-scale bioreactor systems. Hydrochloric acid should never be used as it is corrosive even to stainless steel. Likewise, sulfuric acid concentration should not be given 10% and 80% as between this range. Sulfuric acid is most corrosive. The next is cleaning and sterilization facilities. Small scale reactors are taken apart and then cleaned before being reassembled, filled and then sterilized in an autoclave. However, reactors with volumes greater than 5 liters cannot be placed in an autoclave and sterilized. These reactors must be cleaned and sterilized in place. This process is referred to clean in place. CIP involves, that means clean in place, involves the complete cleaning of not only the fermenter but also all lines linked to the internal components of the reactor. Steam cleaning and sterilizing chemicals, spray balls and high pressure pump are used in this process. The process is usually automated to minimize the possibility of human error. Next is application of bioreactor. Bioreactors are used for the production of biomass, metabolites and antibiotics. This table shows the type of bioreactors and applications. Stirred tank fermenters are used for the production of antibiotics, citric acid, exopolysaccharides, cellulose, chitinolytic enzymes, lactase, allanase, pectic and pectate lyase, tissue mass culture, lipase, polygalacturonases and succinic acid. Next ferment is bubble column fermenter used for algal culture and chitinolytic enzymes production. Airlift fermenter, antibiotics, chitinolytic enzymes, exopolysaccharide, gibberellic acid, lactase, cellulase, lactic acid, polygalacturonases, tissue mass culture. Fluid bed fermenter used for the production of packed bed fermenter used for the production of lactase, hydrogen, organic acid and culture of mammalian cells. Photobioreactor, wastewater treatment, water quality management, remediation of contaminated soils. Membrane bioreactor, alginate, antibiotic, cellulose hydrolysis, hydrogen production, water treatment, VOC treatment. Dear students, I hope you could understand what is a bioreactor, various types, design and its applications. Thank you for watching. See you in next class with another topic. Don't forget to leave a like and please subscribe my channel.